Namaskar, my dear friends. Let us talk about how we can design RC filter in NI Multisim and we'll simulate the same. So what we'll do is we'll see the AC analysis of RC low pass filter, LPF, low pass filter. So you can see very simple resistor and capacitor, this put together becomes a low pass filter and you can see output at this particular place. So the circuit will be very simple. What will happen is we will have one AC source here, let us say 1 volt peak is there, and we have a resistor and capacitor to set the cutoff frequency. So you already know what is the low pass filter cutoff frequency using this particular circuit. So this particular circuit will give me a low pass filter with cutoff frequency Fc is equal to 1 by 2 pi RC. Okay. Now you can see that cutoff frequency can be reduced or increased based on the value of resistor or capacitor. So let us say we will fix the value of capacitor. So to increase the value of Fc, what will happen? My resistance must be decreased. So as my resistor decreases, what will happen? My cutoff frequency increases. So this particular 10 kilo ohm and 0.1 microfarad, you can see the cutoff frequency is minus 3 dB here. Somewhere it will be at this location. So it will be just above or like below than, just above this point. Okay. So you want, you can take a calculator and see what is the value of Fc, and this is how this Bode plot of magnitude plot and this is phase plot is there. So let us open Multisim and see how we can design this and simulate this. So for that, I have opened this particular circuit. You have to put one voltage source here. How to put that you already know. Go to place, component, and here power sources. Go to signal voltage source and here AC voltage. Okay, so this AC voltage you can put it. Go to voltage signal source, AC voltage, press OK, and you can put this AC voltage. Okay. Now put one resistor and capacitor and put grounds, and this is how my circuit is completed. Now to have the AC analysis, what do we need to do? We need to do some settings. Okay, so for that setting, just follow this particular path, otherwise it will be very difficult to set the Bode plot and all those things. So for that, go to simulate, analyze and simulation, and here you have to select to AC sweep. Okay, and in this AC sweep you have frequency parameters as, let us say start frequency is 1 hertz and stop frequency I am going to take 500 megahertz. Okay, you want, you can take it to gigahertz on all those things, so 20 gigahertz, 10 gigahertz, whatever you want you can do that. Okay, but I'm not going to do that. 500 megahertz is more than enough for me, so I'll put it 500 megahertz. Now sweep type is decade type. You want, you can take it octave type, linear type and all those things. And very vertical scale will be what? You want logarithmic, decibel, so I will put it decibel, that is dB, right? And then save it. So this is the setting for simulation. Quickly if you want, you can see again. Go to simulate, analyze and simulate AC sweep, set the start frequency and stop frequency, put the sweep type in decade type and put the number of points per decade, how many points you want. By default you keep it 10 and vertical scale you keep it in decibel. Okay, that's all. Now if you press run, you are going to get nice Bode plot of magnitude plot, and this is my phase plot. Okay, so you want, you can increase this particular size so that you can view it very nicely. Okay, so you can see it is 0 dB and then slowly at the cutoff frequency it is decreasing to minus 3 dB. So minus 3 dB point will be your cutoff frequency point. Okay, now let us quickly change the value of resistor and capacitor and see what is the like change that is going to happen in my cutoff frequency. So as you already know, I'll just reduce this size here, and as you already know that if I reduce this particular resistance value, what will happen? 1 by 2 pi RC, so FC will increase, so it will go more than 100. Here right now it is, I think, 159 uh, hertz. Okay, for this value, so let us make it 1 kilo ohm. Okay, so now it will shift little further, so just remember it is be close to 100, now it will be more. So see, it has reached to this particular point. Understood? So this is how you can change your RC filter cutoff frequency, and this is a very good tool to design your RC filter and set the cutoff frequency that you need for your Bode plot or something like that. You can have a proper look. Now let us change the input source. Okay, so input source, let us say it is going to be 1 volt. What I'll do is I'll put it, let us say 0.5 volt or 0.3 volt. Okay, now let us put together. See, same result it is happening. Understood? So hope you have a good understanding about how to design low pass RC filter circuit. So to make it little better, go to place, put a comment and low pass filter design. So low pass filter design and simulation I have put it, and I'll change the color to, let us say, blue, which is my favorite color. So yes, so this is how low pass filter design and simulation. Okay, and this is my input source, this is my output place, and this is how you design your RC filter. Thank you guys.